Hello, in this video lecture we are going to discuss about the differential equation of simple harmonic motion, and we are going to also find out the solution of that differential equation. So the very basic things are the following: the displacement if represented by y, then first order differentiation, that is dy by dt, is the velocity, and the second order differentiation of the displacement is acceleration, or first order differentiation of the velocity is acceleration. Now, simple harmonic motion always takes place in a straight line, and the characteristic of the simple harmonic motion is a body performing S.H.M. The net force is proportional to the displacement, but the displacement and the forces are in opposite direction. So, we are going to make use of this and go ahead. So, we do know that the net force acting on a particle performing S.H.M. is minus of y, and the net force itself, as per the second law of Newton, is equal to mass times acceleration, where the mass is the mass of the body performing S.H.M. So, that is equal to, sorry, I missed out here, there should be k, a constant, because this is proportionality sign. So, it has to be minus of k times y. Now, this k is known as spring constant, or sometimes it is also known as the force constant, right. So, this is equal to minus k times of y, and m is d2 y by dt2, that is the acceleration, that is minus k times y. Okay. Now, this m goes on the other side. So, d2y by dt2, that is minus k by m times y. Now, this k by m is known as omega square. Omega is angular frequency, that is equal to 2 pi f or 2 pi by t. So, the value of omega from here is under root of k by m. All right. So, this d2y by dt2 plus, or let me write one step ahead, omega square y, take this on this side. So, d2y by dt2 plus omega square y is 0. This itself is the differential equation of simple harmonic motion. Now, we do know in maths that suppose if x square plus 2x plus 1 is 0 is a quadratic equation in one variable. It has two solutions which can be obtained by x is equal to minus b plus minus under root of b square minus 4ac by 2a. You can find out two roots by using this equation, and the answer to the problem are the two roots. In the same way, we need to find out the solution of that. Now, in advance I am going to tell you that the solution is y is equal to a sine omega t plus phi. So, we are supposed to prove that this is a solution to this differential equation. Like here, this was an quadratic equation, here it is a differential equation, because there is a differentiation second order derivative or 2 times differentiation of y. So, this is acceleration basically, and we are supposed to find the solution. So, see how we are going to do that, that is what we are going to look at, right. Okay, let us move ahead. So, now let us find out the solution to the above differential equation by multiplying by 2 dy by dt on both sides. So, this is d2y by dt2 plus omega square y is equal to 2 dy by dt times 0. So, we have multiplied both sides by 2 dy by dt, opening up the bracket, 2 dy by dt times d2y by dt2 plus omega square 2 y dy by dt. Okay. So, this 2 y dy by dt times omega square, here it remains 0. Now, let us integrate both the sides with respect to dt. So, this becomes integration of 2 dy by dt times d2y by dt square with respect to time plus integration of 2 omega square y dy by dt. Now, this whole term is being integrated with respect to t. So, integration with respect to dt. Now, what happens is this dt gets cancelled, this dt gets cancelled. So, we have integration of 2 is constant. So, comes out this is d2y by dt2 times dy plus integration of 2 omega square is constant. So, y dy is equal to integration of 0 times dt. Now, I am going to skip this part and I am going to directly write this as dy by dt the whole square. The interested students may still check out till the last part of the video. I will discuss how this derivation actually came from here to here at the end of this video. So, those students who are not interested in this part may skip that part. Okay. So, this is dy by dt the whole square plus 2 omega square, integration of y is y square by 2. Now, that is integration of this, that is integration of dt, 0 dt is 0, and you will have to add some constant. So, I am going to write that constant as C1, right, because integration of 0 is 0, but we will have to add the constant because there are no limits. All right. So, now our equation finally is dy by dt the whole square plus 2, this 2 gets cancelled. So, we have omega square y square, that is equal to C1. Now, basically this is velocity square, right. So, what am I going to assume? I am going to assume that when y is a, velocity is 0. Why? Because see, when the particle starts from the mean position and when it reaches the extreme position on one side, reaches here, the displacement is maximum, that is equal to the amplitude, and over here the velocity is 0. That is what I have said, when y is 0, sorry, when y is a, velocity is 0. So, dy by dt is velocity and that is 0 when y is a and square. So, C1. So, what do I get the value of C1? Omega square a square. This value I am going to substitute here. So, the equation becomes dy by dt the whole square plus omega square y square is equal to C1, but I have found out C1 is omega square a square. Taking this on the other side, dy by dt the whole square, that is equal to omega square a square minus y square. So, simply I took it on that side, omega square was common. Now, what is this? This is velocity square, that is omega square a square minus y square. Taking square root, I will get the velocity as under root of a square minus y square, and omega is outside. This is the equation of the velocity, right. Now, since we had taken the square root of this on both sides, this became dy by dt, that is the velocity, that is omega under root of a square minus y square. Now, I am going to take this dt on that side and this part in the denominator. So, dy by under root of a square minus y square is equal to omega times dt. All right. Now, I am going to integrate this both sides. Now, integration of this is sine inverse y by a, that is equal to omega t plus c. Why? Because this omega is constant, so integration of dt is t. I am going to write down some constant c2 because we have not used any limits. This is a direct mathematical property, that integration of dy by this is equal to this one. Now, I have sine inverse of y by a is equal to omega t plus c2. Now, sine inverse goes on the other side. So, y by a, it becomes sine omega t plus c2. So, which gives me the equation that y is equal to a sine omega t plus c2. Now, guys, when time is 0, at that time this entire part becomes phi. We know that when time is 0 and if the particle is not at its mean position, at that time we know that the initial phase is phi. So, this entire part becomes phi when time is 0. So, basically C2 itself is phi. So, the final equation is y is equal to a sine omega t plus phi. that is our final solution to our differential equation. Let me show you. Our differential equation was this one. So now we are going to go forward with this part, that how this came this one, right. So integration of this is 2 d2y by dt2 times dy. We are going to prove that this is equal to dy by dt the whole square, right. Now for that I am going to assume the substitution method that dy by dt is say u. Okay. So the second derivative d2y by dt2 is equal to du by dt, correct. Now this dt goes on the other side, so dy is equal to u dt. This is my equation number 1, this is my equation number 2. Okay. Now if I integrate this with respect to, right, and let me multiply 2 on both sides. Now if I integrate, this is 2 d2y by dt2 with respect to dy. So over here also integration of 2 du by dt with respect to dy. Now what am I going to do? This dy value I am going to substitute it over here. So this becomes 2 integration of d2y by dt2 times dy, that is 2 comes outside, du by dt times dy is u dt, dt gets cancelled. So this is basically equal to 2 integration of u du, and this is equal to 2 integration of u is u square by 2. So 2 gets cancelled, right. So what do we have finally? This, which was equal to 2 integration of d2y by dt2 times dy is equal to u square, but u is dy by dt. So dy by dt the whole square. This is the proof. So I hope that you have understood this well. I know this is bit of the mathematical, but I am sure that if you will practice this 2 times, you will understand. Thanks a lot for watching.